Yes. All right. Take it off, Dumitru. Thank you.
Thanks. So, hi everyone. Again, I'm Dumitru, and I was hoping that this presentation would not be immediately after the previous one because it's trying to address some similar issues in a different way. So, it's called horizontal scaling with OVN component templates. Um, when I say scaling, I mean, for example, when you have a cluster with n nodes, you want to add another node. Normally, that means that you need to replicate some of the resources that are on the other nodes on this new node. So you probably need to add a new logical switch if you use OVN, of course. You probably need to add a logical switch, a logical router, and so on. But why do I call it horizontal scaling? Well, I didn't really have a good reason, but vertical was. And it was too late to change the name of the doc, so I kept it like that. But yeah, on a serious note, in OVN Kubernetes, this is how the network topology looks like. We have, for each node, so we have two different types of resources. We have distributed resources, ones that are not in the blue areas, so the OVN cluster router and the joint switch. And we have node-specific resources, like an OVN worker switch, so a node switch, a node gateway router, and a node internal switch that connects to the outside world. The problem we're trying to solve is related to load balancers. In OVN, to OVN Kubernetes services that are implemented in OVN through load balancer. There are two types of OVN Kubernetes services. Cluster IP services that load balance traffic destined to cluster internal IP. And they use backends, quality backends for the load balancer. A service like this translates to a single OVN load balancer, and that load balancer gets applied to all the node logical switches. So it's a one-to-one mapping. And that's good because it scales linearly. It allows us to translate S Kubernetes services to S load balancers, and we use all of S logical flows. That's cool, that's nice. But the problem is with the second type of Kubernetes services, the node port services, these are a bit different because they expose a service via the node IP. So the VIP of the load balancer will be different on every node. So that all of a sudden means that for one Kubernetes services, we need n load balancers. And these get applied on the gateway routers, the nodes, logical gateway routers. That's a problem because it obviously doesn't scale nicely. For S services and nodes, we end up with S times n load balancers of S times n logical flows. But yeah, let's focus a bit on what we're trying to fix here, the load balancers themselves. On the leftmost side, we have the definition of the load balancer. And if we highlight the differences, we see that the only thing that differs here is the VIP. So if we somehow mask it out, we end up with what we have on the right side, just one component template, we call it. So these are, I'm trying to introduce now template load balancers. So instead of explicitly specifying the VIP, we're going to use a component template to replace the VIP. What's a component template? It's something that has a name. Like in OVN, we have other objects that have names, like port groups and address sets. To refer to it, we use the circumflex accent character as a prefix to the variable name, to the component template name. And what's special about it is that it can expand to at most one unique value on every chassis. So it's a template, right? That gets different values on different chassis. To configure that, we add a new table to the Northbound database, the chassis template var table, where per chassis we have variables key value map. For our case, if we look at how we would provision this in the Northbound database, we would have 3 different values, one per chassis for the VIP var. And those values are the node IPs. So going back to our topology, now instead of defining 3 unique resources in the Northbound database, we define one templated load balancer that we apply on all gateway routers. And all of a sudden, at least from Northbound, NorthD, and Southbound perspective, we scale linearly because we end up generating S load balancers for S services, all of S logical flows, and we only need N chassis template var mappings. There is, however, a worst case scenario, and that's when the backends have different sets of pods, or when the services have different sets of pods on different nodes. In that case, we need to use more than N chassis template var mappings. So worst case scenario, complexity is the same as in the current operation deployment mode. So S load balancers translate, S services translate to S load balancers, but they also translate to O of S times N chassis var mappings. But is that so bad? Actually, it turns out it's not. So I did a benchmark. It's a synthetic benchmark, but it simulates what an OVN Kubernetes deployment with N nodes, S node port services, and 5 unique backends per node would be. So I ran the benchmark for 60, 120, 250 nodes, and 1,000, 2,000, and 10,000 services. And yeah, the gist is we could scale to twice the number of nodes, 5 times more services, and all this while using less resources, so less CPU and less memory for OVN services. So if we focus on the middle 2 lines, the 120 nodes, 2,000 services, that's where I actually stopped with testing the baseline because the baseline was taking way too long. In that case, the Northbound database size was reduced by 65%, memory usage went down by 90%, and for the Southbound, it's similar, 95% for size and 98% memory usage. And also, what's interesting is that NorthD loop times went down from 16 seconds to almost 0. That's a lot of improvement. And because the Southbound size decreased, OVN controller memory usage went down drastically. So, all great, even if it's kind of the worst case scenario. So, what are the key takeaways? We can significantly improve scalability. There's a catch here. The resources have to be distributed kind of uniformly in the cluster. Otherwise, we can't really apply this. Component templates are a generic thing, so they could be used for ACLs, for router policies, so on, and for load balancers, of course. But they also require work on the CMS side to define the templates in such a way that the translation is optimal to virtual network resources. So yeah, we can't really automatically implement this optimization. We need help from the CMS to configure it. And we're currently targeting this to be accepted in the next OVN release. That's it. Thanks, everyone.
Thank you so much, Dumitru. Do we have any questions? I guess, do we only have one person asking questions? I mean, Flavio's kind of been asking questions all day. Does anybody else? Anyone else want to go first besides Flavio? No one? Oh, you want to go? Somebody raise their hand? No? All right.
Dumitru, this is awesome, by the way. Do you see issues, or do you already think of issues where you use both? You making changes to the schema, right? And you're going to have a table with load balancers and potentially templates, and they have overlapping, or I mean, is there ever a usage case you think that we have both tables being used?
Maybe, yeah.
And it's okay.
I mean, OVN is generic, so maybe, yes. For OVN Kubernetes, I don't think so. I still think this is the best way to configure it. But maybe for other CMSs, it makes more sense to mix and match.
Yeah,
I'm
or
not
if we
sure.
screw up and our, upgrade forgets to
Right,
delete
if,
the
if,
old
you,
ones.
if you end up using both, it's not going to be a real issue. There's some undefined behavior there, but in theory it should work.
Yeah.
Of course, you should try to avoid overlaps.
Yeah. I guess the only, I think for Kubernetes, when you're doing a node port service, you apply to all the nodes. But I wonder if there will be cases where you want a flag or something in the chassis table that says, oh, by the way, I don't want to participate on this.
But this allows you to do that. You just don't define the template variable on that chassis.
Oh, I see.
You don't
So
create
by just not having it,
if you don't
it's already,
instantiate it on a chassis, it will just be skipped. And it works fine.
Cool. Oh, yeah, no, this is going to help tons. It's
I
awesome.
hope so.
Yeah. Thanks.
All right, thank you so much, Flavio. Any more questions from the room? Do you have any virtual? We do have virtual.
Yeah, I have a question first. How does this play with your last talk? Does it help? Does it not help? Are they orthogonal?
I was hoping nobody would ask.
Sorry.
Right. So we spoke in the previous talk that you might end up deploying ovn-IC in multiple zones, and a zone might have multiple nodes. So within a zone, you might hit the same scalability issue with node port services. Then you could combine both approaches, for example.
But in a pure single node ovn-IC, you would not.
In a pure single node ovn-IC, I don't think you should combine them. There's probably no need.
We have a question from the chat from Roberto Acosta. It says, congrats, Dumitru. Is there any plan to make the oven controller multi-thread? I believe this is a problem for large-scale deployments.
Well, to be pedantic, it is already multi-threaded. We have a separate thread for processing packets, so controller action packets. I'm not aware of any other plans to do it. Maybe we should, but I don't think we spent enough time analyzing if that's worth it.
Just to follow up on Dimitru's reply, I think in all of the OpenShift and OVN Kubernetes scaling work that we've done, we found that reducing the amount of data in the system through other means, through optimizations that just sent less stuff to OVN controller and made it do less work, had a much, much bigger impact that we didn't need to multi-thread OVN controller.
Right, and previously in a similar context, Ilya said you should try to throw cores at the problem as a last resort, right? I agree.
All right, do we have any last questions in the room? Otherwise, no more questions. Otherwise, we can move on. Thank you so much, Dumitru. Thank you so much.